Hello everyone, today I'm continuing with day 19 with the code interpreter from OpenAI. I tried to solve a few days ago day 18 after OpenAI released the code interpreter, and I wasn't able, but it seems very close to being capable, and I wanted to give a shot to some other days that I wasn't able to solve with the original ChatGPT and GPT-4 when I did Advent of Code 2021. Since then there have been a lot of updates and changes in the model that we can use from OpenAI, and I wanted to explore if there is some really a major improvement that will allow us to solve our problem. To simply fastly recap what we were doing, usually I start solving the days using initially Go. However, the code interpreter at the time of this video, it's working only with Python, and for that I'm changing my strategy to use Python and also providing the task description as its own text file that I'm uploading to the UI from OpenAI. And let me simply go here and create a new folder. Let me call it day 19 part 1, and for that we will firstly have a main Python file that we'll use to put our code. We'll have prompts md that will save all the commands that we've been asking GPT-4, or it might be even instead of doing that, actually, because OpenAI release a feature that we can actually export conversation. I will actually do that, and we'll simply export it and have it in our work instead of me copying and pasting and so on and wasting time on that. And having input text, which is a file that I will put my input from here. Right, save that. That's actually the input, and one as well that will be a test text in which I'll be able to actually give a simple test with some expected output from the description. But let's go through the problem simply briefly. We are in bottom of the ocean, we are in the submarine, and our prop is assortment of bacon. As your probe drifted down through this area, it realized an assortment of beacons and scanners into the water. We have a beacons and we have a scanners with which we can scan and find where the beacons are emitting signals. It's difficult to navigate in the pitch black open waters of the ocean trench, But if you can build a map of the trench using data from the scanners, you should be able to safely reach the bottom, which means that we need to build a three-dimensional map of the bottom of the ocean, and we need for that to use scanners to scan the beacons. And what's the challenging with that? The beacons in the scanners float motionless in the water. They're designed to maintain the same position for a long period of time. Each scanner is capable of detecting all beacons in a large cube centered on the scanner. Beacons that are at most 1,000 units away from the scanner in each of the three axes have their precise position determined relative to the scanner. We can detect from the scanner where in the three-dimensional sphere the beacons are, and we have Cartesian coordinates. However, scanners cannot detect other scanners. Okay, we don't know where are the other scanners. The submarine has automatically summarized the relative position of beacon detected by each scanner via puzzle input. Okay, we have information for what so far been scanned, and we know where are the beacons. However, let's see what's the problem. For example, if scanner is at XYZ coordinates 500, 0 and minus 500, and they are beacon set, and the scanner could report that the first beacon is set. We simply adjust where is the position of the beacon relative to the position of the scanner. That's the information that we have. However, we don't know what's the positioning compared to our submarine relative to the scanner, but would not detect the second beacon at all. Unfortunately, while each scanner can report the position of all detected beacons relative to itself, the scanner do not know their own position. Okay, for us, we don't have no clue where are the scanners. You need to determine the position of the beacon and the scanners yourself. Okay, we will need to figure it out where the scanners are. The scanners have beacon map a single contiguous 3D region. This region can reconstruct by finding pairs of scanners that have overlapping detection regions such that there are at least 12 beacons that both scans detect within an overlap. By establishing 12 common beacons, you can precisely determine where the scanners are relative to each other, allowing you to reconstruct the beacon map and one scanner at a time. Okay, from the scanner data we need to find 12 beacons that are common between the scanners and use this information to actually reconstruct the map, and here we're going in more details for the information and so on. However, let's copy the task and put in our new file task text. Okay, that's perfect. Let me look at how we start our prompts. Previously, what we're saying here is we're giving a setup of our task with very common pattern. Let me put still prompts MD. We have this stuff which it's simply our setup. You're a prominent competitive programmer. You have been invited to participate in a programming competition. You're given a task to solve. The task will be provided in text file task.txt. Instruction: write a Python program that solves the task and read input from test text. Did you understand your row and the setup? Let's work this out in a step-by-step way to be sure we have the right answer. Why we need that? Because that it's allowing the GPT model to have a little bit more space and have time to think, so to say, or at least some context in which can use it to gather its thought and after that referring to them. But let's go faster and simply see how it's going. Yes, I understand the role of setups. I'm tasked to write a program in Python that's also given problem. The problem description will be provided in a text file named task, and the input for the testing the program will be given another text file named test. Okay, however, some AI language model have direct access to external files. If you could provide the context and the test files, I would be able to help you to solve the task. And now, what we're doing, let me go to files, code, advent of code. Now that's another advent of code. In this one, we have the task. This is the task. Please provide with the strategy how to solve the task. And good exact iteration consideration are there. So you write consideration. Is that wrong? Consideration. Okay, but English. Amazing. The task implementation. And again, as always, we'll use this let's work this. Okay, I'm asking the model. Here is the task. Please provide me with a strategy of how to solve the task and what exact considerations are the hardest in the task implementation. Let's work this out in a step-by-step way to be sure we have the right answer. Now we're giving again the model more time firstly to read the task. Here we can see it's grabbing the task and saving it some time space. And we can see it has the entire task. And here we can see the summary. The problem involves triangulation position of the 3D space from set of observation made by a number of scanners, each with a different unknown position and orientation. The objective is to determine the total number of unique beacons that have been detected. Here is strategy for solving the problem. That parsing, the first step involving parsing of each scanner provide least relative coordinates to determine the beacon. We need to parse this data into suitable structures such as direct with the scan. Okay, now before to get to did I save the input data? Yeah, I have the input data. We should form a simple test. For example, now I will ask the model to perform a step 1, but instead of rushing it completely, I will provide this test input and will ask to read it as a file and try to came up with output that I want to test. What I exactly mean is here in my, sorry about that, here in my test file, I'll put this one. In my prompt, I'll have go and start writing my prompt. Let's implement step 1 of the plan. I'm providing you with demo test file with 2 errors. Be able to test that the errors detection are read correctly. Okay, I'm simply telling the model, I will provide you with very simple examples to see if we'll be able to handle it. And let's see how the model is doing. What's the model doing? It's reading my test file, it's seeing the scan. Now it's trying to implement it. It's here this parsing information, blah blah blah. It fails here. I should have split the first line on. And what was the split? Okay, the split was correct. Or not correct, but it didn't change. Okay, and now it's getting in almost infinite loop. Let's stop with that and say, actually, let's go with constraints. Each scanner data starts with dash. Let's describing line where n is integer 0 to second objection is the is one. Third, the scammers are separated from each other by empty line. Okay, that are three constraints that on theory should allow to solve it, because as we saw previously was trying to do simply not start with perfect. Okay, now it's falling apart. Oh, it's my example is okay. I see. Because if in the test example they're like I see, are two-dimensional coordinates. I think it's more for a human created to I think I should do it like that, and here this stuff. And let me go here. Let me oh, I cannot re-upload the file. Oh, what? I think it's yeah, I think that's actually bad. Let's stop, man. Put for step 1 of the task. Okay. Yeah, OpenAI should fix that. I think they. Yeah, let's see what is done. The same kind of mistake. Okay, that looks legit. Let me see the data. You complete the task. Yes. This. Let's continue with step 2 of our plan. let's go again back to the prompt, and let me close this other stuff. I will not deal with the task for the moment, and copy our, let's work this out in a step-by-step way. Let's see. What was step 2? Finding overlapping beacon. For each pair of scans, we need to find set of overlapping beacons. Beacons that are seen by the scanners can be done using set operation. Note that the overlapping must be at least 12 beacons for the scan to be considered. Okay, how I can test that? Okay, now here we have smaller example, and we will want to actually push this one, because this one is with 4 or 5 scanners and they have a lot of examples. We would like to give this one now, once we know that the current algorithm is working. Beacons data, and go to test your implementation. Okay. Step 2. Do not one station to make sure that you understand them and they are working as of the same program. Okay, let's. It was very worthy, but no. No. Let me edit this one. The expected results are Yeah, let's see if this amending the prompt and so on will help. Is it true? Yeah, I can see results for. Okay, we're passing correctly the data. We have the scan. Mm, Here is example of how manually some can determine the positions. Why I'm doing that is I want to give example of the thinking process, and here the authors of the exercise already have done. it. Okay, let's see how it will work now. Because here it's this example of okay, now it's able to do the setting. I think it's missing the point. I think here I should stop it and actually go here and mention in the constraints the beacon positions for each scanner are relative to the position of the scanner, which is unknown. I think sorry about that. Let's see if with this kind of information that will help with something. Find overlap. Okay, it's telling you that it's too hard for it. And the problem it's hard indeed. Otherwise I will solve it myself. But yeah, a bit getting again a bit disappointed. Let me still amend with his words. Refresh. Yeah. Good. And test. Scientist. Scientist. Use of combinatoric and geometry. Okay, let's see if that will help with anything. For each pair, determine the set of the 10-0 scanner 1 overlapping. The set, okay, it's 9, it's making like a lookup of the first and the second and now the overlapping. Okay, it seems like try to think the task now with the new information we got so far. To double check your understanding. Okay. I having my favorite stuff and I have the task. Let's see if that will help with anything. It's reading the task. The bacon position. Okay, let's see if that helps with. Let's go. Okay. I was wondering what's happened. How big? Yes. Frequencies. let's see what it's doing. Yeah, it's adding. Okay, now it's trying to implement funding overlapping. Combination 1, combination 2, okay, so on. Yeah, that's a very good approach. I'm really impressed so far, albeit it's still I'm not thinking that we'll be able to solve the problem, but let's see with our small example if it's actually able to find this stuff. It's quite challenging task, because and it at least on theory seems like this kind of adding this constraint that you're very good computer scientist, especially in the field of combinatoric and 3D geometry, it's somewhat like telling the chatbot to actually use its ability. It's a little bit funny. Mm. Okay, let me give a second shot on this one and see if that helps with something. Yeah, I think unfortunately it might fail with this. Yeah, it seems like we'll fail to implement this task again. As I mentioned, this task hits something that will be unsolvable for me apart of brute forcing it, which practically mean we'll not be able to solve it. I won't be able to solve it. That's really complicated task. For that, it's interesting if with a little bit assistance for me with giving some nudges and giving some constraints and trying to help in splitting a little bit the problem to smaller chunks, would it be able to solve it? Fortunately, it doesn't seem so, which is yeah, unfortunate. It wasn't able to do day 18 the last time that I tried. Capsule algorithm. Never heard of that. What's that? Okay, that's interesting. Mm-hmm. Mm-hmm. Okay. 3D points. That's extremely interesting. This is using number pi and so on. Very interesting if managed to do that. I will give it probably less than 20% chance to succeed in that. Okay. With implementing pilot, then okay, let's see if Yeah. Um, okay, let's see if it's something to do with some cache from OpenAI or some crap like that. Not sure what the OpenAI team is doing. It okay, now it's trying to implement it and so on. It's actually, yeah. Okay, I'm thinking now, once it's crashing, is to ask it for so far the entire program that it's implementing of these steps, and after that I will feed it to it as input in another prompt. Uh, mm, Here is the test, and all the is part of the test. let me give the task. Let me go here. Let's give our favorite thing. I would not be surprised if it's not capable to do the task really. I mean, that's one of the hardest tasks. I think it's only up to day 25, it's only one or two. That seems a little bit harder, but some of the found ones, at least for me, seems easier. And I was able to solve some of them, but the previous day and this day, they're very complicated and involving a lot of thinking and algorithms and so on. It seems enter the name. I can. Yes. Let me see if we'll be able to do it like that. Yeah, it seems. Yeah, it seems it's getting there, but it's not really yet. Okay, that's nice. Lesson and caps over data and read the what that we have so far. And meanwhile, mm, I can't. Some worse, some worse. Oh, it's getting there, but it seems like we'll need to have at least 2 to 3 other improvements to be able to solve tasks that actually involve knowledge of complicated algorithms and approaches to dimensional space and so on, and probably using advanced data structures. Already it knows basic tree algorithms, also graph algorithms like Dijkstra, but yeah, definitely not capable to do. Yes, and this is a new file input text and give me the answer. Okay, the final input, and if I run day 19 part 1, day 19 I think here I need to give print. No? Yeah. Then I test this code with this one text. I'm getting 64 instead of 79. Yeah, so check yourself. Yes, and check performance with performance 48 simply wrong. Yes. Yeah, it's a bit. It's definitely encouraging how close is to come to this solution. Also, it's somewhat concerning. Yeah, how to fix mistakes in this implementation and so on, because here it's using all that logic that's absolutely unknown for me. Here is using some yeah, some rounding up and so on, some kind of guessing. It's it seems like the approach it's hmm, Yeah, let's see if it's. Yes, and let's do this. Oh. Here. From one was invented this algorithm. Yeah. 76. Mm-hmm. Well, that's stage. Yeah. Almost done. Yes. And and here the final problem. Wait. Oh, want to test it myself. Mm-hmm. Yeah, I think it's. Mm-hmm. Very nice. Here if I go to the Python program, he's telling me how to code. Okay. Okay. Yeah, let's see. I would imagine that that's the end of it. Yeah, unfortunately, it doesn't seem to be working. It cannot be 13. Mm-hmm. 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 No, no, the wrong. Mm, this getting. Oh. Mm. Okay. Simply refresh it multiple times and see if we'll be able to do it after 10 refreshes. No. Yes. Let's see. Let's see what to drink. Mm. Okay, doesn't seem capable of doing it. Okay, let me copy this version in the code and add it there. I didn't change much of it. Yeah, it seems interesting approach with code interpreter and with the code interpreter. It seems more capable, definitely, but still not able to really solve really challenging tasks. I mean, it's able to solve challenging tasks, but not above the abilities that already had. We were able with GPT-4 to get to the Day 17, even here solving 2 of the days. Some of the other I solve it later on myself, but yeah, getting to the day 17, it's incredibly impressive feat, but was already GPT-4 was capable for that. To get to this new one, I would assume we will need to wait for more updates from OpenAI. I already tried day 18. I have the similar kind of issues. Was quite close, but not exactly there. Day 19, the same story. Then let's wait and let's hope that OpenAI release in the future a new, more capable model. Thank you for your time. Hope that was somewhat informative and helpful in some way. Have a nice one.